Virtual Life Cycle Manufacturing นะคะบรรยายโดยมิสเตอร์ซานโตชNagaraju นะคะเป็นผู้เชี่ยวชาญทางเทคนิคในภูมิภาคอินโดแปซิฟิกของบริษัท MSC Software นะคะดูแลงานทางด้านวัสดุและการผลิต Over to you Santhosh
So I'm Santhosh Nagaraju. So today we will look at virtual lifecycle manufacturing. So throughout the presentation, if you have any question, so feel free to stop me at any point of time. I'm more comfortable with more interactive session. So virtual lifecycle manufacturing. So before we start, so I just want to put a couple of points which is of my experience. So I have worked in manufacturing industry as well as in the software field. So today the industries were majorly looking at industry 4.0, like adoption of industry 4.0 and smart manufacturing solutions. So this is a solution. So you can go to any manufacturing industry or supplier and you can propose on this particular kind of platform we have. So I strongly suggest pay attention to it. So it might be easy selling point for you because every manufacturing industry looking for this solution. VMC, or we call it as virtual lifecycle manufacturing, or we call it as ViLMa. So if you have any question, for example, after my session, or if you want to reach me any point of time, please write to me or you can directly reach to me. So what is ViLMa, virtual lifecycle management in the sense? So today, the industry 4.0 or major manufacturing trend, they are shifting towards the smart factory, or you might have familiar with autonomous data flow or autonomous processes. So in this, so when we talk about industry initialization today towards smart factory, so we have solution which talks about connecting devices and system. In the sense, how do I connect my scanner? For example, if I scan a component, how do I take that scan data into my CAE software in the form of STL file? So connection between the hardware device and the software, or we can call it a system. So we have solution on this. So then we are talking about deploying advanced technologies. So when I say advanced technology, so it might be of optimization tool, CAE process simulation tools. So how do we integrate this advanced technology tools into the current manufacturing industry? So if we can go to any manufacturer and if you can present on this solution saying that, so if we have any scan data or data which is taken during the prototyping or manufacturing, so we can use that data in the CAE software tools, because now we have a lot of IoT tools which can do the optimization of process. So where we talk about deploying the new technologies. Then use of data again. So how do we use the current measure data? It might be of the temperature measurement, the quality measurement or inspection during the manufacturing of a part. Then it might be of a scan data, or it might be of CMM measurement. How do we use all of this data so that software or our technology can suggest you what is the best way to manufacture the particular component? So this is where smart factory is all about. So it talks about connecting hardware and software and using the advanced solution and use the existing data from shop floor to to optimize the existing process. So what are the solutions we have for that? So if you go to any manufacturing industry, so they might be having different departments like design department, engineering department, prototyping and manufacturing. So each department will work separately. Like design department will have the CAD related data or virtual measurement data. So engineering department will be more working on designing, taking the drawings input from design department. Prototyping and manufacturing, so they are more on actual or physical testing, where they will do the actual manufacturing processes. The manufacturing is like how do we implement in the large scale on the shop floor. So what we do is we connect all of this, like we have a platform where we can integrate simulations in each stage, like I can do a design, in the sense I do the CAD modeling of a particular design. I send it to engineering department for the analysis, like whether my CAD design will take the required load, what is the durability. Those study will be done in engineering department. Then it's go for a prototyping, in the sense testing, physical printing of or physical manufacturing of couple of parts and checking the functionality of the design we finalized. Then it will go for an actual production or a large scale production. So all of this, so we can support with our multiple tools available. Like when we talk about quality inspection, we have CMM, we have scanners where we can use. So when we talk about advanced simulation, so we can use advanced simulation from MSc software. So if it is of more manufacturing, then we can use SimuFact. So SimuFact can and FTI can offer any metal-based manufacturing process simulation. For example, I have a design, and while manufacturing, I have some problem with the distortion. Our design is deviating from my original design, or I could not able to meet required design tolerances. In that case, I can use software tools to optimize my design so that I can manufacture it with a given tolerance, and I can manufacture a best quality of part with whatever resources available in the factory. So then comes the optimization tool. So it might be of optimizing your component for lightweighting, optimizing for performances, optimizing during manufacturing process, as well as taking the feedback from the quality and inspection. Then we can further work on the design changes. So all of this can be done, and all of this were integrated when we talk about ViLMa solution. So you can take the actual scan data, you can integrate those with MSc software tools. Also, you have option where you can do the data management analysis, autonomous in the sense, transferring results from one department to another department without any data loss. So that with the single platform, you can do all of this processes, like we call it as digital twin of complete manufacturing processes, which includes design, engineering, quality, and manufacturing. So I could see some comments on voice clarity. Hope I am audible, right? Can someone confirm?
Yes.
Okay, thanks. So what are the simulation tool we pitch into? So when we talk about design and engineering, it is purely we talk about MSc tools. So you find out a customer. So he might be of sheet metal component manufacturer. He might be of just doing a body welding for a OEM, or he might be doing just a component level manufacturing for the major OEM or auto maker. So just find out them so that we can pitch design and engineering tool, which is of lightweighting or material reduction, topology optimization. Then when it comes to engineering, what will be the durability or strength of that particular component once we done the lightweighting. So when we go to the prototyping, maybe I have, so this is an example of when we go to the prototyping or manufacturing. This is an example of Audi where we had an autonomous workflow. So we start with press shop, so where we get the component from different supplier, because when we say about, or when we focus on car manufacturing, so there are multiple supplier, not whole frame will be done by single supplier. So door will be manufactured by supplier A, then the frame will be done by supplier B. So before it reaches the OEM, so we can scan the door manufactured at supplier end and take it into our ViLMa platform and see what is the gap between frame and the car door which is manufactured at supplier B. So like that, before it actually assembles, we can have the visualization. For example, as I said, if we have a different supplier, you can just scan the component which is manufactured and send that scan data into OEM. So we can receive the scan data and put it into mainframe and understand, okay, So where are the deviations and how best it will fit, and what is a flush graph and other things. So if there is some rework required, so that we can immediately send him the feedback saying that the deviations need to be corrected, so that there is no logistics involved. Like you need not to send the physically manufactured card over to OEM, then they will put it into mainframe and understand what are the deviation, then again send it back to the supplier for the rework. All of this workflow can be reduced with our ViLMa solution. So this is an example we have already implemented with Audi. So where they will get part from different set of press shop or suppliers. They get they scan the moment it's manufactured at a supplier end. Then they will fit with the mainframe and understand how best it will fit, or how best is a design and tolerance, or GT and TD we can. So once it is done, so now I have the complete BIW, body in white. So then I will go for a crash analysis. So before I physically go for a crash analysis, then we can use MSC software solution. So since we have all actual manufactured data, so we can use the same and do the crash analysis, or if you want to do the multi-body dynamics or durability of an individual component, all of this can be done with our advanced process simulation. So this saves a lot of time and money for any manufacturer. So this is where we can talk about ROI. So we can go and talk to the industry. If you invest on this tool, so you have a lot of you can avoid rejections, because the moment it manufactured, you come to know what is the accuracy of the component which is produced at different press shops, so that there will be not much rework and time spent on any new model manufacturing. So this is a greater advantage of this tool. So they will really see the benefit, and we can justify ROI, return on investment, on this particular tool. Any questions here, this particular slide?
มีคำถามไหมคะสำหรับสไลด์ในส่วนนี้ก็สามารถเปิดไมค์สอบถามได้นะคะก็ทางนี้เปิดโอกาสให้ลองถามดูเพราะว่าอันนี้เป็นตัวอย่างที่มา implement จริงในตัว Audi เลยนะคะถ้าเกิดท่านใดมี case study หรือที่ปัญหาอยู่ใกล้เคียงก็สามารถสอบถามได้นะคะ
Okay, so if no question, maybe they can reach to me or you in the later.
Okay.
Stage. Thanks.
Please go on.
So this is a solution. So if any of the customer is working on prototyping and manufacturing, so there are some supplier who may not be more interested in design and engineering tool, because they are not responsible for doing a design and engineering. They will get the geometry from OEM. So their job is to only the manufacture as per given drawing or design. So they will not have any control on the design and engineering. So for them, so we can go and suggest tool where we talk about the CMM tool or measurement. So we can go to their shop floor and understand how the quality or inspection is done. They might be doing or they might be using CMM for the dimensional accuracy, or they might be using scanner for the whole body scanning. So in that case, we can go to them and whichever manufacturing or measurement technology for the manufacturing industry, which is of CMM, coordinate measurement system, portable measurement arm, then laser tracker, we have white light scanner, and this is more flexible. It can be adapted for any kind of measurement. So you can go to any manufacturing industry and talk about our inspection tool. The greater advantage, so all of this scan data can be directly converted into CAD model or STL model. So there are a lot of competitors when it comes to scanning, but not everyone can do those conversion of the scan images into the STL file, so that we can use for further FEA analysis or the data preparation. So this is the solution if any customer is only doing a manufacturing point of view. So if they are not into the design and engineering. So if we have a manufacturer, so what are the solutions we have? For example, we talk about supplier who is doing a car door manufacturer. So you don't have any control on design changes. So we can go to him and we can talk about the inspection tools, which we have seen in the previous slide, or we can go and talk to him on how do we control the distortion or how do we optimize our existing process. So you might be doing RSW welding, or you might be doing gluing between the small component and main frame, or you might be doing brazing or any type of welding or a hemming process in the sense of mechanical joining and hemming process. So we can go to them and we can talk on individual process optimization. So if they are doing a riveting, so we can go and suggest them. We have a rivet optimizer. It tells you which is the best way to rivet so that you will have better strength and you can avoid the distortion during riveting process. If he is doing a welding process simulation, so we can go and tell him that if you are welding with 3 robos, so we can optimize and welding path. So in order to control the residual stresses and distortion, also in order to improve the productivity of the process. So these are the solutions we have. So if we're going to the tier 1 or tier 2 supplier, so we can go to that respective manufacturing processes. It need not to be only welding or mechanical joining. It might be of sheet metal forming or 3D printing. We have solution from the manufacturing point of view. So if it is of OEM, so we can combine all of this: design, engineering, prototype, and manufacturing. So we have solution for each stage. So we have solution for design, we have solution, we have a process simulation tool for engineering, measurement tool for a prototyping, then process improvement tools, which is of again Simufact and FTI. So all of this can be combined together under ViLMa solutions. So if they want to have their own kind of GUI where they want to monitor all this process, we can create a GUI based on the customer request. So this is an example of how data-driven workflow works. So this is stamped at the customer location. Then we have this is the stamped part. We do scanning and it captures some critical dimension and the car door. Then it was sent to the OEM. So then they will certify whether this is, or they can send a feedback that whether this is okay or not. So that if it is okay, so you can start shipment. So if not, then you will rework and correct the critical dimension in the given design. So this will save a lot of logistics money. Also, this will save a lot of time for actual car manufacturer. So this is a critical or pain point for any car manufacturer and supplier. I think they are really looking for this kind of solutions. So this is another example of how this data-driven approach was taken into the hexagon digital thread, which includes manufacturing, process simulation, then measurement, then ViLMa platform where we will gather all the data and see the fitment and assembly level monitoring. Then we can suggest them for if there's required any modification, then it can be done on this final data management tool we have. So all of this data can be saved in our cloud-based solution we have. So at the end, so if we can go to the any of manufacturing industry, there might be working end-to-end, including design to quality, or there might be only focusing on design or manufacturing and prototyping. So we have solution for each stages. So we can go and talk to them and we can optimize the existing process so that they can save a lot of time and money, so that their investment, they can justify their investment with us. So conclusion, so we have a high performing digital twin solution based on the CAE technology, in a sense simulation tools. Also we have manufacturing error prediction, which is more like optimizing the current manufacturing processes with high-end technology, then optimizing the complete end-to-end solution, starting from design to the quality. So you can pitch any of this solution based on their area of focus. So what it makes, it gives more innovation driven, like they can change the design, it become more flexible. Then they're agile, in the sense they are flexible, or any design change can be acceptable at any point of time. We can improve the accuracy of it, and it is more customer oriented in the sense, so we can reduce the scrap, we can reduce the material waste, so that also same time we can improve the profitability of any factory or any manufacturing unit.